What is negentropy?
Must be movement.
The negation of entropy.
It's the what?
Negation of entropy.
It's order of cow.
Close, yes.
Order of cow.
Order from chaos, yes. Yeah. Negentropy, I have a little clicker here. Well, that works. Right, okay. So, you're all familiar with a glass being knocked off a table and smashing. That's supposedly the whole order of the universe. It's just increasing disorder. But many of you, have you got children? Put your hands up if you've got a child. You've got relatives that have got a child. Probably most of you got a relative, are a child, were a child, have ever had a spot. There are things that you've experienced in your life where things become more ordered. You take raw materials and you give them to something that is living, like a tomato plant, and the soil, the water, the sunshine that doesn't have particular order, and it's putting order into that. Negentropy, for me, more than anything, is about life. Okay, and essentially, negentropy is about order and organization. Negentropy indicates how much a system is organized and structured as opposed to being chaotic. Okay? Life and systems, living organisms are often considered negentropic because they maintain and create order. So, like you get a spot on your face that looks like disorder, the end of the world, but you know, your body clears out that thing and your body maintains the skin, yeah, hopefully. Despite the natural tendency towards disorder. So there's all things trying to attack your body, all things trying to attack your tomato plants. The tree gets a cut in it, a branch gets blown off by the wind, right, by chaos, but the tree heals itself. The plant grows another stalk or whatever, and it has this ontological will, this determination to order its environment to achieve its goal, which is maybe procreation or provision or something like that, or creation of ideas in the case of humans. So I'm going to talk about the push model of gravity. The push model of gravity, also known as Lesage's theory of gravitation, this was an alternative theory to Newton's law of universal gravitation, and it's actually came out with another guy called Greenyer in 1690, so it's a very old idea. But it was Lesage in 1748 that kind of really crystallized this concept, okay? And this concept was the prevailing theory of how gravity worked. Even Tesla believed it until Einstein sort of came onto the scene. It relied on what Lesage called ultra-mundane corpuscles. These were some incredibly small things that came from everywhere in the cosmos. And it relied on the fact that these things were pushing against everything. So if you had a single body in space, it was pushing from all sides. But if you had, for instance, a ball above the ground, you had some pushing it, and there was a gap in between where there's a kind of shadow, so there's a less pressure in that gap. And this is what's called the shadowing effect. So if you have two bodies, they shadow the particles, these ultramundane particles that come from either side in between them, and so the bodies get pushed together. So this was the theory of gravity that basically prevailed for a large amount of the last several hundred years. It relied on non-elastic collisions. That is where the energy doesn't always get fully reflected, and so on. The problem with this theory of gravity is it doesn't allow for absorption of the particles in any way. They might pass through things, or they might partially bounce off things, but they don't get absorbed. So there's no technical gravitational wave. Gravitational well, rather. There's nothing for the particles to sink into. Okay? So what we have here is a promotional video that I did. It's only 3 minutes long, and I hope you'll be able to hear the sound. If it doesn't come from there, it'll come from here. Thank you, Ava. And it's for a book called Space, Earth, Human, originally published in 2009 by one Dr. Alexander Parkhomov, a fellow of the Russian Academy of Sciences. I had the pleasure of meeting this researcher in February 2015 in Moscow and going and working in his home laboratory. It's a wonderful, wonderful place. I'll give you a little anecdote whilst Ava's getting hooked up there. He was running a nickel hydrogen experiment, a cold fusion experiment so-called, a low-energy nuclear reaction experiment, in one part of his lounge. Meanwhile, we were eating in the other part of the lounge and the dog was walking around.
So he was recreating Andre Rossi's experiment?
He realized that, as Andre Rossi's description was, it didn't work. And I think that's because at the time, no one had clocked that probably the lithium aluminium hydride was separate from the nickel, right? Everyone thought they were mixed together. The lithium aluminium hydride was just a source of hydrogen. He realized, as we did, that the lithium aluminium hydride broke down to lithium hydride, but it coated the nickel, so it prevented it from working. So his systems were predominantly just nickel hydrogen PN tele, who I talked about earlier. Okay. So he was doing this experiment, and I said, aren't you worried about the chemicals that you're using here? And he goes, no, I'm not worried about these. I'm worried about what I have in this cupboard. Because he used to work for ProAtom, and he had, and if you see in his book, he had things like plutonium and so there's me eating the biscuits and having the tea, and there's some plutonium over in the cupboard. Okay, all right. Knowing what a minuscule amount can kill you, it was curious. Because he didn't tell me he had plutonium there, but like you would look at his book and you know he must have done. Right. So I'm going to play this video. It's just 3 minutes long, and then we might go back and stop at a few places. Okay. I will stop, and you can take some pictures, because in the slides that's in this video, there are QR codes, and you can go and read the 4 key papers that are necessary to really understanding what I'm going to be talking about.
So we need to read them before we talk about them?
No. I'm just saying, there's one thing about taking my word for it, and I know I've been wrong many times in my life, and I may be wrong now, sorry. It's just the way it is. But I'm giving you the summation of my understanding, but like I'm giving you the opportunity to see the workings. Yeah.
Is this online now, Bob? Or?
This video is online. Yeah. I've just copied it into the presentation here for expediency.
If you are interested in connections between the cosmos and man, or in ways to tap the unlimited sea of energy in which we live, then please help enable the English translation of this Russian book, Space, Earth, Human, by scientist Dr. Alexander Parkhomov. My name is Bob Greenyer. Since 2012, I have been supported by an international community of wonderful people just like you.
Same shit.
Volunteer for the open, not-for-profit Martin Fleischmann Memorial Project.
Shifting over.
Scientists across the world are waking up to the role that neutrinos might play in how everything in our reality works, and how they may enable the next chapter in our history. Russian research has been ahead of this trend, conducting focused experiments for decades, and this book, first published in 2009, reveals a spread of work by a real pioneer in this field. Alexander Parkhomov is updating his book, including latest data for this new version, and I feel it is imperative that his results and related insights is read as widely as possible. We need you to help us raise $7,000 to make
Actually, I don't.
and tested the full end-to-end translation and book formatting process. For every reward level,
And we don't need to see this.
enabled this up. British physicist Charles Barker followed his 1909 discovery of elemental characteristic X-rays by researching what he called J radiation, which ultimately neither he nor his contemporaries could ever explain. Austrian physicist Wolfgang Pauli said of his 1930 proposed neutrino, "I have done a terrible thing. I have postulated a particle that cannot be detected." French economist and physicist Maurice Allais observed peculiar movements in a Foucault pendulum during a 1954 alignment of the Sun, Moon and Earth. Just 2 years later, in 1956, the American physicist Frederick Raines detected neutrinos. The following year, in 1957, the Russian physicist Ivan Filimonenko is said to have developed a neutron-free palladium and heavy water heat-producing reactor that also produced reactionless force and a strange emission that affected radionuclide half-lives. From the early 1970s, Russian inventor and scientist Alexander Chernetsky found that high-frequency plasma discharges could produce excess energy, reactionless propulsion, and emit waves that could penetrate metals and accelerate beta isotope decay. From 1979, Canadian Tesla enthusiast John Hutchison discovered that by combining high-voltage static electricity with various interfering electromagnetic waves, he could initiate cold elemental transmutation, deactivate radionuclides, create anti-gravity effects, and fuse dissimilar materials. From the early 1980s, American inventor Kenneth Shoulders discovered that electrons could be made to self-organize, enabling excess heat, reactionless propulsion, radionuclide deactivation, elemental transmutation, and X-ray production. In March 1989, electrochemists Stanley Pons and Martin Fleischmann announced that they had achieved excess heat and transmutation in a palladium and heavy water electrolytic cell. In August 1989, Italian scientist Francesco Piantelli discovered that nickel and hydrogen produced excess heat and later confirmed transmutation. Between 1989 and 1994, Japanese nuclear scientist Takaaki Matsumoto established that both palladium, deuterium and nickel-hydrogen systems produce transmutation, disappearance of material, and strange cracks in X-ray emulsions. He conceded in his later years that he had replicated the observations of Kenneth Shoulders. Between 1987 and 1999, Chinese researcher Xu Wenju's team found that during Sun, Moon and Earth alignments, an unusual force of horizontal oscillation takes place. This affects the grain arrangement of lead-tin alloy, the spectral wavelengths of atoms or molecules, and the speed rate of atomic clocks. In 1992, while spinning high-temperature superconductors, Russian scientist Eugene Kotletnov observed local gravity modification and claimed the waves propagated faster than light, and the beam could cause fusion of dissimilar materials. If we can exceed the goal of $7,000 need...
Hopefully from that, you can see that there is a large number of scientists that did not work together that established a range of strange phenomena, which even today people are taught are impossible. They had no reason to claim independently without anyone else knowing the same things that they were observing. And it's from the same family of devices and approaches. So I'm going to go back to those slides which had the key information on, and I'll just give you a summary of what is important there to understand. So this is Japanese research, and they are observing relic neutrinos being reflected. Okay. What are relic neutrinos? We're going to show you that in a little bit. So we're going to be talking about this a lot. Relic neutrinos, or cosmic background neutrinos, were apparently born at the birth of the universe, if you believe that story. Okay? They are pervasive through the entire universe, and because they weakly interact with matter, they pervade actual all matter. They go through matter. These structures would be a model for this ultra-mundane corpuscles. Okay? The kind of thing that was described by Lesage. They are extremely ubiquitous. So what you saw in this video was research that was conducted by, this is the updated book, by Dr. Alexander Parkhomov. And you saw a color photo that I took in his, which was still running. It had been running for nearly 30 years. That's a long experiment, by the way. Here. Somewhere here. There. And what he has here is a sardine can, very important. And a bean can, also very important, because they hold the electronics for the Geiger counter. Okay? He has an old chair leg here and part of his old forest house. Very, very important. Okay? He has this, which is a pan lid, and he used the hole where you would put the screw and the thing. Yeah. The pan lid, because he used all kinds of different materials to find out what materials were better at reflecting this substance. Okay? If you look at these windows, I'm sure many of you can see these windows. We know that the window can pass light, because that's why we have them, right? To get light into the room. But as I'm looking at that window right now, I can see a reflection of the tree that I can't see in a direct line of sight. And this is because it's a partially reflecting surface. Okay, same as the kind of Pepper's ghost effect. And condensed matter, that being, in this case, the steel in the pan lid, can partially reflect the relic neutrinos, these clusters thereof. And so it's like a radar dish, and he's focusing that at a target in here. And this is where it becomes stuff you can't get from your grocery store or from a skip. He's got a piece 1 millimeter by 1 millimeter by 1 millimeter of cobalt-60. Cobalt-60 can only be produced by neutron interaction with iron, or cobalt rather, 5960. It is a beta isotope, and it decays with around about 3 or so, 4 years half-life. Okay, so it's a much faster decay even than tritium that we were talking about earlier. These relic neutrinos can cause that to decay. Now, if relic neutrinos couldn't be reflected, the decay rate would not change. If these things were not neutrino-like, they couldn't force the decay of the cobalt-60 to accelerate. So using this piece of apparatus, and when I said, like, you know, why don't you have a budget? He says, well, like after 1992, when essentially he started this experiment, everyone was made unemployed because the Soviet Union was spending some ridiculous amount of its money, like 25% or 30% of its GDP on research for, you know, science and war, right? A massive amount. It had 50 Manhattan projects and nothing was off the table, right? Psychotronics, advanced electromagnetics, and we were just making bombs, yeah? So these geniuses that really understood a lot were then thrown out. And he said he got most of his equipment out of the skips outside of when they were throwing everything out. Right? Because they didn't have any money to even host it. They needed to use the space for something else. Okay? Now, has anyone heard of Hal Puthoff? You've met him, right? Yin's met him. Actually, Yin knows personally John Hutchison, so if you want some insights there, then. Hal Puthoff ran what was called the US Psychic Spy Program, the men that stare at goats. Yeah? This was transferred in 1992 to Science Applications International Corporation in San Diego. Which is a Central Intelligence Agency cutout organization. Yeah. Basically, this was for anything useful developed during the Cold War, was parked with this pseudo-private entity. So that no one could do a freedom of information on it. Anything that wasn't moved there was useless, and you can know it if you want. As long as it's useless. Now the interesting thing is, chapter 4 of this book is all about Alexander Parkhomov's work doing the Soviet psychic spy program. It's that work that taught him about how to detect this type of radiation. You have something to say?
What's the name again of the military goods guy?
Dr. Hal Puthoff. He's US Naval Intelligence. Harold, or short Hal, H-A-L, P-U-T-H-O-F-F. Okay. So when he chose beta isotopes, he would get, during the annual solar year, over a very long period of time, these changes, can you see those? Each of one up and down there is 1 year of experimentation. Okay? Very, very long-term experimentation. And what this is the Earth, the Moon, the Sun, in fact all celestial bodies have what's called a neutrino sphere. And it's this material that is in denser concentration around planets and moons and suns. Because neutrinos can be affected and affect two things. One, gravity, and two, weak interaction. Gravity, I think you're going to be more familiar with. Weak interaction is the thing that we're interested in when we want to synthesize matter and desynthesize matter. So here's the thing. In the spring in the northern hemisphere, what happens?
Yeah, the days are getting longer.
Think life. What happens with life?
Life's emerging.
Why?
Light is growing, or what you're saying.
There's more things than just light.
Yes.
This is, in my view, the chi, the life force, the prana, the Holy Spirit. And this enables a seed to germinate much better than it would at any other time. Unless you could generate an artificial flux of relic neutrinos. Which means you can just as adequately... So there's the neutrino problem. They didn't know why they weren't getting enough neutrinos from the sun. And this is because they found they were changing states between three flavors of them. They were going from electron to tau to muon, electron, muon, tau, and oscillating through their types. It's not relevant in this case because these are ultra low momentum neutrinos. These are not the same as nuclear neutrinos. In fact, the sun produces a lot of them, but they do not have enough velocity to escape the sun's gravitational well. All matter is energy. It's wrapped into some form of coil that's stable. Now, as I said earlier when we were talking with Paul, it's unnecessary to clean a window with one piece of lint in the cloth. Let's start with the cloth, because I can actually do the job, right? At some point you have to decide where you're going to draw the line, and if something, the cloth, is the neutrino, and it's able to explain all the things we're about to discuss, then we don't need to look at what the lint is. We can just say this is already partially, the work is already done for us to a degree. And then we can use that for everything else. Okay. So I'm going to go back to those papers, and I'm going to address one each in turn. So this is showing that independent to Alexander Parkhomov's work, some Japanese researchers found that they could reflect relic neutrinos. Okay. In this paper, done by some Italians here, they found that if you used beta decaying nuclei, these could capture neutrinos. And you could find out that it was capturing them because you are causing accelerated beta decay. The way that Alexander Parkhomov did this is, if I can find the chart, when a normal nuclear decay occurs, you get, in this case, a beta. What you have is you have a neutron, and it decays into a proton, electron, and an antineutrino. The proton stays in the nuclei, and the element progresses, say, from carbon to nitrogen, one element along the periodic table, let's say. That's what happens when carbon-14 decays, producing a beta particle, an antineutrino. Now, these antineutrinos are not the neutrinos I'm talking about. This is what's called a nuclear neutrino. Okay, so it's just a balancing equation, and that's what Pauli came up with. There must be something that accounts for the lost mass, and it wasn't until Raines found it in the 1950s that we agreed it exists. And in fact, scintillation, that is light flashes in a cubic meter of water from this process, is used to determine the plutonium production rate in a normal fission reactor if you want to know how fast you're going to be able to make bombs. Yeah? Now, what is being discussed by here and being discussed here is what's called inverse beta decay. So what's happening is some form of neutrino-like particle is entering into our matter and annihilating the antineutrino, and you only get the electron out and the proton stays in the nucleus. Okay?
Is there a name for that?
Inverse beta decay. And in normal beta decay, the energy that's released in the reaction is shared between the electron and the nuclear neutrino. Okay? In this case, there is no neutrino that comes out. And so you get all of the energy going into the electron that comes out. And it's called Emax, and this is the chart. So ordinarily, your, just so everyone can see it, ordinarily your spread of energy of the beta particle, the electron here, will be a spread. And the balance of that energy will go to the nuclear neutrino. Okay? In an inverse beta reaction, you only get the energy of the electron at Emax, because there's nothing else to share that energy with. Okay? It's stronger. And so on his telescope, where the cobalt 60 is, which is a beautifully dense target of beta isotope, which he's focusing this thing from the cosmos, he has sheets of aluminium that discriminate for all of these energies. So all you see coming out is this, which means his signal to noise ratio is much higher. Imagine you're in a room and you're in an apartment building, and next door someone's playing some loud music. Well, you're not hearing all the high frequency sounds, are you? You're just hearing the boom, 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 right? That is what you're detecting. You're hearing the boom. Yeah, not the boom, for those that know I say boom, the boom. Okay? So that's what you're looking for. And this means you can know that this came from inverse beta decay. It is not a normal natural decay. Now, some natural decays will produce this, but very few. Okay? So that's how he was able to prove it. So other people have shown that, and typically they're using tritium, but tritium's not a dense material. Cobalt's a metal. You've got a lot of atoms in a small space. Tritium, not so much. Okay? The next point here is this paper by CERN Theory Group, specifically Bob McElrath. And he says here in his conclusion, cosmic background neutrinos, the type that we are talking about, the type that doesn't go at the speed of light nearly, that is not interacting with 9 light years of lead. This thing is so slow it can't even escape the sun's gravity, right? It interacts with matter. It says, cosmic background neutrinos must exist. They are a superfluid, and their self-interactions are a gravitational theory. These dynamics arise in the standard model, which is renormalizable quantum field theory. We suggest that this may actually be the gravity that we observe. This is CERN, I think it's in 2009. And it's their interactions between these particles that leads to a model of gravity that is compliant with the standard model. So everything I'm going to tell you does not need woo-woo physics, but it enables woo-woo physics. Right? And that's so cool, because we don't need to get the scientists all upset that we don't agree with them. We just say, you haven't considered this, what it can do. The last paper you should refer to is David R. Andrews. This is not so much a top tier paper, but he reflects on the condensates of neutrinos. Now, a nuclear neutrino, very fast, highly energetic, barely interacts with anything. A relic neutrino is at just a little bit under 2 kelvins. You don't want to stand in 2 kelvins. It's really cold. And do you know what? We're all standing in it. All of the time. It's here with us where we are. It's a superfluid fermionic condensate. And it pervades all of space-time. And when you have... I want you to just all wave side to side. Just all wave side to side, right? Okay, even the guy on the phone. Or maybe not. All waving side to side, right? Now, at the moment, you're all out of sync, right? Right? So in each row, grab the person next to you, right? Yeah, and I'm going to give the same instruction. Wave from side to side. Okay. So here's the thing. All of you were moving out of phase beforehand. You were all your own little island. But when you were able to come together, you couldn't move out of sync, because like one's pulling the other one, and if you didn't have enough energy to move, you get pulled with the other one, and you're effectively sharing all your energy. And this is what I was describing yesterday about matter in a condensed state. Like I talked about lasers and phasers and coherent matter generally. Okay? Now, when you're all in that sync state, what happens when you create coherent matter? You typically, in the past, you would consider to cool it down to near absolute zero. Why? To get every part of that matter at exactly the same kinetic energy. And then you have a substrate, and the substrate is your chairs, let's say, and the fact that you're linked together by the substrate. The substrate are your linked arms. And that is where you have your, let's say, sodium-23 atoms on a plate. And there's a famous experiment, you can go and see it on YouTube, the synchronization of metronomes. So you've got like a metronome like that for, doing your piano playing, 4/4 or whatever it is, yeah? And you've got another metronome and it's going like that. You put them on some sort of substrate, and after a while, they all end up in sync. It doesn't matter whether you have hundreds and hundreds and hundreds of them, right? And so that is how you can think. What you've just done there in this metronome experiment, you can think that's kind of what's going on. They're sharing the energy until they've all got the same energy, and then they're all in phase. Okay? Now, what does that mean? In super scientific terms, they're saying that it shares the same wave function. Okay, sorry, don't, scary, okay. What that really means is, at every point in space and time, if you have an influence, it will be all of that coherent matter instantaneously. It's not necessarily the ball pushing, it's that you're pushing the same ball. You understand? You've not got a load of Newton's cradle there and it goes over there because it's transmitting the energy through the incompressible substance. In this case, you have a ball here and you have the same ball here and you have the same ball here and you have all the way to the other side of the universe. And when I do an influence on this particular structure, every single structure in the entire universe feels it. When you understand this simple principle, then you can understand how twins can feel information about their twin. You can understand how remote viewers can see back through time and across time. The psychic spy programs. Why? Because they are tapping into the echoes, the ghosts, the apparitions that are there stuck in the Akashic record. The Akashic record, this is also a model for the Akashic record. So, the principles that he establishes from considering that...
Akashic records, is that a new term? Akashic records?
It's like a Sanskrit thing, yeah, and it's kind of like...
Who doesn't know or who knows?
Who doesn't know? You know, like generally? So a quick
Yeah, it's basically, it comes from, as I understand it, from Indian scripture, and it's basically where the knowledge is stored or comes from. It's like source. And everyone gets a key to that, and you basically get downloads from it. That's how I understand it to be, is that...
Everything that's ever happened is stored in a field.
Yeah.
You go to it when you, for example, when you fall asleep, just before, it's actually about the frequency in the hemisync in your brain.
It's like when we see stars in the sky, they're millions of light years away. We're back referencing the Akashic records of a million light years backwards in time. In reality.
And in fact, this is very interesting because one of the things that's listed in Parkhomov's book here is the use of this technology to see backwards in time. The reason is because light travels at sea, and this doesn't even travel fast enough to get away from the sun, which means you can see celestial events that have happened millions of years in the past in real time. If you know what I mean. You can see the progression of events that may explain the order of the current structure of a particular galaxy by looking at the neutrino flux, the relic neutrino flux. So he's described a different telescope. It's like someone sending Morse code by light and another person sending it by banging a drum, right? One's going to arrive a lot less quickly, and so you're going to receive the information later.
A question. The speed of transmission of information is infinite or just very, very big?
So what you're, yeah, it's instantaneous when you're interacting with the material's toroidal moments, right? So you're actually interacting with the condensate. When the flux is different. The speed at which this flows is different. So yeah,
You have to explain me better later.
yeah, it's a weird concept, and also the thing about condensates is you can have the same thing here and the same thing here, but this is same but different. You understand what I mean? Because you can have more of the same thing occupying this bit of space-time than you have over here, and this is what I was talking about, the neutrino sphere around the moon and the Earth and the Sun. Yeah.
Is this the physical basis of the Berlin inequalities?
You will have to explain what the Berlin inequalities are. Come and explain. No, please.
I don't want to make it too...
No, go on. No, come to the mic, so.
Yeah, okay.
Introduce yourself.
Hello, I'm Tiziano. I do physics. I collaborate with another guy which is very into the foundation of quantum mechanics. So one of the things that that interest us so much is how it is possible for physical systems to have statistical correlations at distance which cannot be practically realized by exchanging light signals. There must be some other connection and correlation. And there are various possibilities to why this happens. One is that distance is an illusion and actually everything happens in one point. Or another possibility is that there is another way of transmitting signals which is way faster than the speed of light. And then, other possibilities. Again, that's why I was asking, because...
So I'm saying it's the latter.
Okay.
I'm saying we know that these particles exist.
Okay.
We know they're all at the same temperature.
Okay.
we know they're a coherent condensate, and therefore, if they're coherent, then regardless of the density, local density, they pervade everything, all space and time. And if you interact with via the toroidal moment with the toroidal moment of these structures, then you can insert information that persists in the superfluid permanently.
Okay, but it gets instantaneously everywhere in space.
Because it's all the same wave function.
Okay. Yeah.
Because people, when people first...
Keep it slow.
Have you finished? When people first produced condensates that were predicted by Bose and Einstein a long time ago, I think it was 96, 97, that with some cesium or sodium atoms, what they found was a little bit. They could only make a little bit. And so it's very difficult for people to understand, you know, how a little bit would also work across the entire universe, right? But that is just a problem with our own ability to perceive things. You know, the first transistor wasn't all of the computers we hold in our hand. But we have that now, so we can understand that that big thing that was a transistor back then, we can have billions of them in our pocket. So it's kind of like that, if you think about it. Does that help you?
Can I
No, I want you to stand there. It looks nice with the light. Carry on. Okay, so.
Paul, just a little side note quickly about the Akashic for Taylor. Taylor, next time you're traveling through India and you come across a Vedic astrologer, maybe Jordan has had this experience, so he will make an appointment for you at a certain time of the day, right? And it's quite unusual because he will be measuring the shadow from your body. And then he will consult his charts and formulas. But the Akashic record is a preordained horoscope. He's not making he's just figuring out for you how to tap into the Akashic records, which are prescribed. They're already done. And certain libraries in India that the Vedic astrologers use have written on these beautiful palm sheets. So that astrologer just has to figure out how to tap into that, but it's a preordained horoscope for you, the individual. So watch out when you're in India.
So do I want to go know that or
Yeah.
no?
Well, if you want to know about yourself.
Oh, so
It's
worth
only
doing?
one gonna die, right?
Vedic astrology is phenomenal.
He won't tell you when you're gonna.
Okay.
Oh, you don't know, that's unethical. You never, a good astrologer would never comment on that.
And if they do, don't believe them.
Yeah. No, they would never do that.
Right.
Could I ask you just to very shortly summarize the most important properties of this superfluid, of these neutrinos? Because I've got a little confused about the different sorts of neutrinos, which is fast, which is slow, interacts matter, doesn't interact with matter. So, yeah. So
Nuclear neutrinos are the sort of neutrinos that come from nuclear core reactions, which are basically when a thing has a normal half-life, like tritium, let's say it's 10.17 years or whatever it is, that it has a stability and something happens within its own sphere and of exposure, and it breaks down, and it breaks down with the nuclear neutrino and the electron, the beta particle. Okay, that nuclear neutrino is traveling very close to the speed of light, and it ostensibly doesn't have any mass. Okay, these relic neutrinos were left over in theory from the birth of the universe, but Dr. Alexander Parkhomov established in his work here, and he shows every experiment and the calculations, and there's nothing more you need to know and to experiment to prove this to yourself. There's a whole series of experiments in here that led him to that discovery. But he found that they can be synthesized from condensed matter at over one relic antineutrino and a relic neutrino. Okay? And the velocity of these things is so slow that they have a de Broglie wavelength of microns to millimeters. That is why they can be partially reflected by a pan lid. Okay? Because they don't go, it's like, think of it like this. Has everyone got like 2.45 gigahertz Wi-Fi? Yeah, and you know you can get a signal around your house, right? Yeah. But then you install the 5 gigahertz Wi-Fi and you walk outside the front door to have a sneaky one or whatever it is you do, and you find out that you can't get your Wi-Fi and you have to step back in, right? That's because that higher frequency interacts more with matter, okay? So different frequencies will interact with different material, you know, depending on it and the material, okay? And so this low frequency hangs around long enough, and because it's neutral, it pervades through trillions of atoms, such that the statistics, which are very, very low, get higher and higher and higher until you actually have perceptible nuclear reaction rates. Okay. As I said, just around about 2 Kelvin. And people think that, sorry, plasma is the be-all and end-all. However, plasma is one part of condensed matter, as I've just described. Okay? And all luminous matter, all stars, all plasma, everything observable in the universe, electrodynamically, is just 0.4% of the energy of the matter in the universe. Energy and matter, dark energy and matter. The dark matter is 22%. Okay? Now, of course, if you don't believe in mainstream physics, you can forget about this, but anyway. Of that dark matter, up to 2% is neutrinos. So potentially, even if we're not looking at interacting with any of this other dark matter, there is 5 times as much potential in the dark matter in terms of energy that we can use than there is in all of the observable matter that we can see in the universe. Right? So even if a small, small fraction of those neutrinos were relic neutrinos, then you have a situation where there is a pervading substance that exists throughout all of the universe that we can tap into if only we can find a way. We found a way. But before we get there, I want to talk about Alexander Shishkin. This is a fellow person who remote views, right, in Russia. He receives information. He's a leading nuclear scientist. It's weird when you go to a conference of people that literally made the Russian nuclear bombs and warheads. And then this guy walks into the room and they all want his attention. They all sit around him and they're keenly listening to his new insights. Alexander Shishkin worked with Vladimirovich Dubovik, who discovered the toroidal moment in Dubna. It's a city, it's the nuclear city for the Soviet Union. It's 50 kilometers north of Moscow. In writing his thesis in 1965, which he published in 1967. He, Alexander Shishkin, and another character called Korols, is another guy called Korols. They believe that ordinary matter has a nucleus, the electrons, and what the Russians call the hidden energy within matter. And that is a condensed cluster of what they call background neutrinos or relic neutrinos. Okay? And then I had 2 questions when I was a child. I didn't read any novels, go figure. My parents actually never read a book, both of them. But they wanted me to read something, and they bought the entire Encyclopedia Britannica, so they gave me £5 for reading a volume. My first question was, when I was reading these things, was, why are all the elements where they are on Earth? I understand why now, through the journey that I've been on. It isn't because they were all made in some supernova and rained down, and for some reason all the aluminium's on the west coast of Africa and all the iron's in the middle of continents. Like, and why is it that heavy elements sink to the center of the Earth, but the lead is very abundant on the crust? Doesn't really make any sense to me. But we now have a model that makes sense. But what happens is, this relic neutrino condensate, which is all at 1.9 whatever Kelvin, has still got energy. And what Shishkin, Karols and Dubovik did was explain for me my second question about the universe, which is what keeps those electrons spinning around an atom perpetually? Because there's no perpetuum mobile, is there? So how does that work? There must be some energy interchange that keeps those in a stable state. Well, what they have demonstrated or believe is that there is a toroidal moment caused by this fractal toroidal cluster of cold neutrinos, background neutrinos, relic neutrinos, ultra-low momentum neutrinos, all names for the same thing, okay? And it pulls the matter in to the core. If the electrons are under-energized, they extract a little bit, just to keep them in their orbit. And then it spits out the slightly denuded relic neutrino clusters into the environment, and they recohere with the condensate, because they're basically at the same energy anyway. Just like when you started off moving, you weren't moving in sync, and then suddenly you were, right? You're out of sync when you come in, and the whole universe shares the energy back to that one that came back out. If the structures are over-energized, they're overexcited, what then happens is the electron shells, through the electron's toroidal moment, share the excess energy out to the condensate. So there's a balancing act that's mediated by the electrons that keeps atoms stable. Now, when you understand this, what else do you think it gives you insight to? What?
Rotation of the Earth.
Yeah? Anything else?
Electricity.
Yes? What else?
Gravity.
Very good. Why?
Because it explains the push.
Yes, it does. Yes, it does. Very good. So, if you are made of atoms, and let's hope everyone is, yeah? Every single atom in your body is interacting with the flux of this material, okay? It's going through every single atom in your body. Now, what you're going to understand later, and you're going to physically, well, you're going to see the physical, the matter that's been physically created through this process from this rarefied material, is that this process is going on in the Earth. Okay, now, does everyone know what a steam engine is? Yeah? Steam engine. Like the tram outside, yeah, right. Does anyone know how much bigger steam is than water? Dry steam.
1200?
It's definitely at least that. If you take 100 degrees water and you make it 100 degrees steam, it changes in volume 1,617 times. Okay? Now, Alexander Parkhomov has established that these relic neutrinos are around about 1/4 of 1 electron volt in mass. Okay? Now, if you consider there is a thing in the Earth that is taking this rarefied material, which after all is just energy in an enclosed form, and it's repackaging it into protons, and let's say the proton is mass, mega electron volts, about 938 million electron volts. So you take 938 million, divide it by 0.25, and you get the number of these rarefied particles that can be condensed into one itty bitty proton nuclei, right? This is creating a proton out of something that is not ordinarily there. And the Earth is growing because it is collecting mass, not just the ejections from the sun, but this constant flux. that's coming in. And life itself is doing this all of the time. Water crashing against the shore, water coming down the stream producing cavitation. You'll understand that all of these processes are creating these toroidal moment structures that are able to capture and harness and resynthesize and build matter. The Earth wasn't made as it is now, but the answer to how this technology works is the crustal abundance. Now, what does that... You've got a steam engine piston here, and it's full of steam, dry steam. And we put some liquid nitrogen on the outside, and let's hope it doesn't shatter the steel, right? You instantaneously get that steam to become water. And what happens? The piston goes like that. Now imagine you've got things in the Earth that are condensing this super rarefied, ultra mundane particles into matter, condensed matter, right? It's going to be pulling that stuff in continuously, isn't it? All of the time it's going to be pulling in from every part, yeah? And what does that do? That creates a gravitational well, because it's constantly being condensed. It's constantly pulling that piston in. It's never pulling it in and pushing it out. It's just pulling it in. It's going, come on, I want more, I want more. I'm building stuff. I'm making a planet. Yeah? Over and over and over again. And what that does is there's more of this stuff up there, and there's a negative pressure of this stuff down there, and it pulls through every atom in your body, and you are pushed onto the gravitational body. It is a model of gravity. And condensation of it, the condensator of the Earth, allows for this because it goes through. It also explains inertia. Because if I'm having to move through this and increase my flux through me, I kind of have to get all of my atoms in some sort of stable state so that I can move in a direction. So where's the...
If you are in the next...
Sorry, did you have a question?
If you said I have 938 million
Electron volts.
Divide,
times 4.
Are necessary to build one proton.
if you say energy is interconvertible with mass, then yes.
But does it mean that at the very same time, kind of, and I imagine that must be a very large scale toroid or something like that, so many neutrinos must be captured so that I build one proton? Or it's just a slow flux of neutrinos which after time is put into a proton?
Either way, it's just, the planet, like I say, it's grown a certain amount over the last 900 million years. Here's the thing. Why were dinosaurs big? Why were dinosaurs big? The gravity was less. Why was gravity less? The planet was smaller. The same chemistry building the bones could, allow a pterodactyl to be the width of this room. Because it literally weighed less.
So we're getting
Small
smaller.
aliens are from the future.
I know, small aliens are from old planets. But they still take the same sacred geometry form. Yeah, like, if we've only been a civilization for, let's believe the mainstream science, maybe 5,000 years, right? If we forget Göbekli Tepe, and we don't think anyone knew anything before they started building these calendars at a 500-year interval, right? Then, our evolution has been quite short, and our knowledge building has been quite short. But imagine some of the planets, even in our own galaxy. They're 2 billion years older than us. And assuming they haven't got upset with each other and thrown bombs at each other, imagine what they know now, right? But 2 billion years of growth, well, that's like, let's say, 35% of the age of Earth or something like that, right? It could be quite a lot bigger planet, so typically their gravity would be higher, and you would imagine these super intelligent beings actually not being very tall because they're still made of the same chemistry, right? Well, you have to imagine the flux of these things is not minuscule.
Okay, so it's rare, but not so rare that it's not enough to have these effects.
It's a vast amount, and when you are near a gravitational body, there's more of this stuff to work with because it begets material coming towards it. A black hole is sucking in a lot of this stuff very quickly. right? So from this paper, he's saying if the density of neutrinos is changed, then the speed of light may change. If the spin stiffness changes, then the speed of light may change too. If the relative speed of neutrinos can be increased at temperature of the condensate, then eventually the de Broglie wavelength will become shorter until the NFC ceases to. So he's explaining some properties, but go and have a look at it. But the most important one there is the speed of light changes because probably light might be needing to interact with this material as well. Okay? Because if this is something to do with what's called the permittivity of the vacuum, then maybe you change the speed of light, time changes, and also electron behavior changes. So you have access to like unlocking things that aren't ordinarily possible. You can also condense matter out of less condensed material, so you can take electrons and condense those, because if you just convert everything into energy, it's 511 keV, kilo electron volts for an electron. So 2 of those makes 1 MeV, so you can make a lot of you know, when you get baryon decay, like a proton or a neutron decaying, it breaks down into leptons like electrons and muons and other stuff that then breaks down into electrons and other bits. So there are stable quanta of matter. And if you can grab some stable quanta of matter, you can condense it. I'm just saying that if gravity is extremely weak compared to the electric force, 40 orders of magnitude smaller. And that kind of chimes in my view, with the rarefication, the rarefied material that I believe is the model for gravity. Okay.
It's interesting, Bob, because it's given a very good scientific explanation in what we've known in Taoism since the beginning of their philosophy.
Please share, because I don't know anything about Taoism.
Well, very simple. You know, we have the push-down theory as well.
Right.
Because what we call cosmic chi, or heaven's chi, not religious, but heaven's chi, or the yang chi, is so much stronger than the earth chi. So the heaven's chi is coming into the planet, particularly strong at the poles, and the earth chi is obviously pushing back out. So heaven's chi is a lot more stronger. So, you know, we receive heaven's chi obviously through the yang meridians, and the earth chi through the yin meridians, but heaven's chi is pushing us down because it's 7-to-1 part strength. But you just explained it completely with the differential.
You need that differential, which was never in...
In Taoism, we're just walking in antennas, so we're receiving that energy, but it's stronger.
Yeah, but we need the Earth to be able to live, which is why you have problems, in my view, in space, because you don't have a body that's able to get enough chi flowing through your body, so parts of your physiology change for the worse.
Floats away,
yeah.
You can manipulate, you know, in martial arts, we manipulate gravity all the time.
Oh, because you said chi, I'm going to go to a straight different presentation now.
For instance, if I was just kind of, all I have to do is visualize being a cloud, and you could come and lift me up, and I'm quite light, right? Then I do this with the students all the time. Then I visualize, now I'm in my hara, I'm in the center, and you come along and try and lift me up. Same person, you wouldn't get me off the ground. Like in martial arts, you wouldn't get that Aikido guy just off the ground. Particularly stronger in women, because they have the earth charge here, much. In martial arts, the women are stronger because they're more grounded. So it's a complete manipulation of gravity.
Fascinating. Thank you, Roger. I had no idea.
You're learning.
We're all learning. And as I said at the beginning, I may be wrong, but I'm quite lucky. Yes. This is the cloth cleaning the window rather than the lint in the cloth.
Repeat the question.
Yeah, so he was basically asking, is this the prima materia that connects everything?
All points in space.
All points in space-time.
Your answer is?
My answer is emphatically, I believe so. And I'm not saying it's the end of the... It is reducible. This isn't the atom of the Greeks. You know, this is reducible, but at some point you can draw a line and say that this can model everything we can see, and we can actually detect it, we can control it, we can manipulate it, and we can use it to do work for us.
It's made it much more concrete.
Yes. Yes.
And how does it tie to the ether?
Well, the ether might be, so when they describe this structure, and I can give you the papers, maybe I'll dig those out. In fact, it's on my blog. I translated the Russian on my blog, so you can go and see it. They're saying that this toroidal cluster of background neutrinos is comprised of a vast number of microleptons, which the Russians call microleptons. It's not even considered in the West, because the West already knows how everything works, and that's why nothing works when they try to build it, right? But anyway, it's made of little bits. The big one is made of little bits. Yeah, and they call them microleptons. And I can show you the equations for how many they consider are in one of these clusters. Okay. Okay.
That is the concept of ether. That was the question.
Yes. Yeah. This, for me, I personally do not need to go any further than this to explain all of the observable properties that are accredited to the ether. You can transmit information instantaneously at any point in the universe. It is a medium over which light can travel. Changing its property, its density, will change the speed of light. That will affect time itself. It'll also affect the properties of electrons. How do we perceive time? And don't say it for those people that I've already said. How do we perceive time?
Through our bodies.
Yes.
That's all I got.
That's a good start. Thank you.
What did you say? Through your body?
Through our bodies.
Yeah. That's through our senses. Yeah, aging. Oh, yes.
Specifically.
Yeah, okay. But what is going on in the process of aging?
Decay.
Very good. What is going on in the process of decay?
Breakdown. Deterioration.
I get an apple, I put it on the table in my kitchen, and none of my kids are eating it. What's happening to the apple?
Eating itself.
Yeah, getting there. What's happening when I'm touching my face? Yes. How do we get friction? Yes, yes. Everything is to do with electrical interactions. When you have something decaying, when I have that signal sending that information up my body, there is a progression of electrical influences going up. When that person is aging or that fruit is decaying, there are chemical reactions going on. If you can stop chemistry, if you can stop the way an electron behaves, dead, you stop time. In all meaningful senses for the way that we perceive time. If you can accelerate the way electrons behave, in all meaningful senses that we perceive time, you can accelerate time. Okay, so it's kind of electron interactions, and what have I said? It's this flux that controls the stability of electrons in matter. If I'm going to shoo a chi bolt at you, I'm sending you something that then has to interact in a way with your body such that it's an electron interaction. But I'm using something that has a toroidal moment, it's a cluster of toroidal moments, and it interacts with the toroidal moments of the electrons and changes the behavior of that. And because you are a conscious being and you create toroidal moments in your brain, and the chi that comes out of your body is connected to your consciousness, you can strike intention with that.
Yes, so you are going so fast.
Sorry.
That there is no way to do it.
Sorry, it has to be done like that, otherwise I'll lose my flow in that particular type of instance.
Another sentence slow was
Yeah.
good.
Repeat a
So,
little bit.
Ava, again. We are electrical conscious beings. We can produce a thing called the toroidal moment in our brain, and that drives intention. We can project into these things that come from our own body. They stream out of our fingers the whole time. And if we're good at it, we can share that intention and put it into other things. That's the presentation I'm going to go to now.